Okay. All right. Okay. So here's another one, the square root of 72. So now we have to wonder, is this simplified? Well, 72, I mean, you could list all the factors, but we know 9 itself is a factor. And 9 is a perfect square. So right away, that tells us the square root of 72 is not simplified. Okay, so let's simplify it. What do? Well, we bring the 9 in front. We have to factor it out. What's left over? You divide, and you get 8. And, oh boy, I can fix that quickly. That should be a 9 times 8, 72 times 8. Okay? That's what we get here. And then, once we have the 9 out, right, we factored it out. That was step 1. No, excuse me, step 2. Step 3 is we use this property, the square root of a product is the product of the square roots. And the square root of 9 is just 3. We have 9 as 3 squared, and 3 is non-negative. But now we have to, 1 second please, but now we have to check if 8 is simplified. Does someone have a question?
Yeah, I was wondering, like, how do you know to use 8 and 9? Like, how come you didn't use, like, 2 and 36?
I could have used 36. You're right.
Oh, it'll still
We
come
could have
out.
used 30. I'm sorry?
It'll still be the same answer, and you'll just have to keep going?
Exactly, yeah.
Oh, okay. Thank you.
Okay. You're welcome. I mean, the book actually says to find the largest perfect square that is a factor. So in that case, you could use 36. That's really good. Whoever said that, very good, Alyssa. That was you who said it, right? Okay.
Yeah, that was me.
Okay, very good. Yeah, 36. But so you could use that, and that actually would save a little bit of time, because once we get down to here, 3 times the square root of 8, we can ask, well, is this simplified, the square root of 8? You know, you want to check if it's simplified. And it turns out the answer is no, because 8 has 4 as a factor. So what do? We factor out 4. Again, 8 has 4 as a factor. 4 is a perfect square. So the square root of 8 is not simplified. So what do? We factor it out, right? I mean, yeah, you divide to get the other factor. Although I hope people know that 8 is just 4 times, well, I hope that comes out right. But I think everyone, well, anyway, you could divide to get the other factor, and we get 8 is 4 times 2. So the square root of 8 is the square root of 4 times the square root of 2. And the square root of 4 is just 2, as we know. So altogether, when everything falls in place, you get 3 radical 8, which is 3 times 2 radical 2, which is 6 radical 2. If you use 36, since 36 is a factor of 72, you would still get the same answer. You would actually save a bit of work. I guess I underestimated everyone. I didn't think that people would know 36 is a factor. I was afraid to put it on there and people would be like, how did you get that? But if you can find the largest perfect square that is a factor, it does make the calculations a bit easier. You don't have to do like more than one simplification. Awesome. Okay, are there any other questions? Again, I'm like out of it because I haven't been sleeping well, so oh boy, please bear with me. Okay, let me do one more thing, then I'll give you guys another worksheet to do. Rationalizing a denominator, it just basically means you don't want any radicals in the denominator. I mean, originally I used to teach this because I used to use my math lab, and that would require students to rationalize the denominator. but I don't use that anymore. I use lumen, but it's still, I think, a good thing to know. And again, to rationalize the denominator, that just means you want to remove radicals from it, any kind of radicals. And here we're looking at square roots. Now you might be thinking, how do you remove radicals from the denominator? You're going to use this property. This is different than what we saw already. You know, if you take the square root of something and you square it, you get the number back. If that number is non-negative, which is what we are dealing with. And this is what we're going to use. This is essentially the calculation here. You know, if you have something like b over radical a, where b is any number, what you're going to do is you're going to multiply top and bottom by the square root of a. On top, you'll have b times the square root of a. On the bottom, you'll have the square root of a squared, which from the top here is just a. But you can't, so here we're rationalizing the denominator. In other words, we don't want any, radicals in the denominator. Okay, so let me just do some examples. We have this one here, 1 over radical 2, which is also on the next slide. I don't know why I put it twice. Oh well. But anyway, to rationalize this, again, you could just multiply top and bottom by radical 2. Because on top, you'll have 1 times radical 2, which is just radical 2. On the bottom, you'll have the square root of 2, radical 2, that is squared. But again, by this here, that's just 2. So this is what we get. And I know it was silly. I put the same example here twice. Get rid of it. I'm not sure why I did that, but oh well. Anyway, this is the next example. 3 over radical 5. Same idea. You just multiply top and bottom by the square root of 5. And why does that help us? Well, on top, you get 3 square root of 5. On the bottom, you get the square root of 5 squared. And that's just 3 radical 5, square root of 5 over 5. If I see radical 5 here, I mean the square root. So, but that's just what we get here. Okay. All right, any questions on this? Okay, let me get the worksheet up. All right, let me just minimize that. Let me get the worksheet showing. I mean, I did email it to everyone. I figured it'd be good to work on it for about 5 minutes. So, okay, so this is the worksheet. Let me just zoom in a bit. It's just basically messing around with with numbers, I guess. So, I mean, you can't see everything here. Although maybe I could fix that. Let me do that. Well, I think I emailed it to everyone, so I want everyone to work on the worksheet that I emailed. Okay? So, take a few minutes working on that. Take about